Welcome Militarist channel. Space has become the newest strategic frontier of human technology.
Thousands of satellites now orbit our planet in carefully calculated paths. These orbital systems connect continents through secure communication networks. What began as exploration has evolved into essential global infrastructure. Navigation systems rely on satellite precision measured in fractions of a second.
Atomic clocks in orbit synchronize the modern world with extraordinary accuracy.
Observation satellites provide a continuous view of our changing planet.
Advanced sensors in orbit monitor global activity in real time.
Secure communication depends on resilient space-based infrastructure.
As more nations enter orbit, the space environment becomes increasingly complex.
Access to orbit begins with advanced launch infrastructure and precision engineering. Low Earth orbit hosts many of the satellites that power daily life. Medium Earth orbit is critical for global navigation systems. Geostationary satellites remain fixed relative to Earth, enabling continuous communication coverage. Ground stations maintain constant communication with assets in orbit.
Monitoring orbital traffic is essential to prevent collisions and maintain safety.
Even small fragments of debris can pose significant challenges in space. Building a satellite requires meticulous engineering and extreme precision. Solar arrays provide continuous energy to sustain orbital systems.
As reliance on space grows, nations establish dedicated space organizations to manage orbital assets.
The United States maintains one of the most extensive satellite networks in orbit. Dedicated space organizations coordinate and protect critical orbital infrastructure.
China continues to expand its presence in orbit through advanced satellite systems and launch capabilities.
Several nations now operate independent navigation systems to ensure strategic autonomy.
Russia maintains a long-standing presence in space through navigation and communication systems.
European nations coordinate their efforts through shared space programs and satellite networks.
India's expanding space capabilities reflect rapid technological advancement. Commercial constellations now form an increasingly important layer of orbital infrastructure. As more nations expand into orbit, competition shifts toward technological superiority and resilience.
Modern space infrastructure is designed with redundancy to ensure continuous operation.
Secure data transmission remains essential to maintaining operational integrity. Space domain awareness centers monitor the orbital environment continuously.
Tracking systems help maintain safe distances between thousands of orbiting objects. Protecting space-based systems now includes advanced cybersecurity measures.
Innovation in orbit continues through experimental platforms and new technology. Modern satellites can adjust their position to maintain optimal coverage. Managing space traffic is becoming as important as managing air traffic on Earth. Independent satellite systems ensure continuity of critical services.
Earth's orbit is becoming increasingly crowded with operational assets.
The modern space race is defined not by territory, but by technology, resilience, and innovation. As reliance on space grows, so does the importance of protecting orbital infrastructure. Modern satellites are designed with protective shielding against radiation and environmental hazards. Encryption and signal protection help safeguard communication networks in orbit. Monitoring for electronic interference has become an essential aspect of orbital operations.
Space-based sensors track objects and maintain awareness across vast distances.
Some nations research anti-satellite technology, prompting discussions about stability and regulation. Maintaining orbital stability is critical to prevent cascading debris risks. Even small objects in orbit carry immense kinetic energy due to high velocities. International efforts aim to reduce debris and preserve orbital sustainability.
Autonomous maneuver systems help satellites avoid potential collisions.
Cybersecurity has become as vital in space as it is on Earth.
Redundancy ensures that critical systems remain operational under unexpected conditions. Distributed constellations reduce vulnerability by spreading capability across many platforms. Laser communication promises faster and more secure data transmission in orbit.
Space weather monitoring protects satellites from solar radiation events.
Precision maneuvering capabilities enhance operational flexibility in orbit. International agreements seek to preserve stability and cooperation in space.
Transparency initiatives help reduce misunderstandings in the space domain.
Responsible deorbit procedures contribute to long-term orbital sustainability. Defensive space strategies prioritize resilience, awareness, and technological reliability. Continuous software updates strengthen satellite performance and security.
Artificial intelligence assists in managing the complexity of modern space operations.
Autonomous coordination improves efficiency across large constellations. Future sensor networks aim to enhance global monitoring capabilities. Data fusion enables comprehensive situational awareness from space. Layered architecture strengthens the reliability of space systems. The expansion of space technology raises important ethical and regulatory questions. Competition and cooperation coexist in the evolving space environment.
The future of space will demand careful coordination and innovation.
Stability in space will depend on responsible technology and shared global stewardship. The future of space security is defined by resilience, awareness, and innovation.
Artificial intelligence will increasingly manage the complexity of orbital coordination.
Autonomous satellite fleets can operate as coordinated networks rather than isolated systems.
Quantum communication promises unprecedented levels of data security in orbit.
Future sensor platforms aim to track high-speed objects across the globe in real time.
Space-based solar power could provide sustainable energy from orbit. On-orbit servicing may extend satellite lifespans and reduce debris.
Modular platforms allow satellites to evolve without full replacement. As exploration expands, communication networks may extend to lunar orbit.
Monitoring cislunar space will become increasingly important in the coming decades. Deep space tracking networks expand humanity's reach beyond Earth orbit. Orbital monitoring systems also contribute to planetary defense initiatives. Robotics will play a central role in maintaining future space infrastructure. Advanced propulsion technologies promise more efficient orbital maneuvering.
International cooperation may define the next era of space exploration. Future infrastructure may extend well beyond Earth's immediate orbit. Multi-orbit architecture enhances resilience and redundancy. Automated traffic systems may prevent congestion in crowded orbital paths.
Data transparency will support responsible governance of the space domain.
Reusable launch systems reduce costs and increase orbital access. Orbital refueling could extend mission duration significantly. Space-based AI systems may coordinate thousands of assets simultaneously.
The expansion of orbital systems may extend into deeper space regions.
Shared platforms can foster cooperation even amid competition. The responsibility to preserve space lies with all who depend on it. The frontier of space continues to expand beyond traditional boundaries. Innovation remains the central strategy in the modern space race. Stability in space depends on responsible technological advancement. Space is a shared domain that connects all nations. The future of space will be shaped by innovation, cooperation, and careful stewardship. As space infrastructure expands, long-term strategy becomes essential.
Tomorrow's orbital systems will operate as interconnected layers of technology. Artificial intelligence may guide the coordination of increasingly complex constellations.
Precision timing will remain the invisible backbone of global systems.
Protecting critical infrastructure in orbit ensures stability on Earth.
Coordination between nations reduces risk and strengthens resilience.
The economics of space now influence global development and connectivity.
Rapid innovation cycles define the modern space race.
Sustainability will determine the long-term future of orbital activity.
Competition in space increasingly coexists with cooperation. Monitoring beyond Earth orbit will shape the next era of space awareness.
The frontier continues to move outward into deeper space.
Advanced propulsion technologies may redefine long-distance orbital travel. Robotics will sustain infrastructure far from Earth's surface.
Integrated data streams create a comprehensive picture of global activity.
Responsible stewardship ensures that space remains usable for generations to come. The responsibility to preserve space belongs to all who rely on it.
Behind every satellite, teams of experts guide operations from Earth.
The space race of today is measured in decades, not moments.
Technology must be matched with trust and transparency.
space-based systems connect billions of people every day.
In silence, satellites perform their duties far above Earth.
The orbital environment grows more complex each year. Innovation in space does not require conflict, only vision and precision. The future of space depends on balance between competition and cooperation. Responsible deorbiting protects the shared orbital environment.
Long-term planning will define humanity's presence in space.
Awareness beyond Earth orbit will shape strategic stability.
The future may connect not just nations, but worlds.
You are watching Channel Militarist, where we explore military and aerospace technology in an educational and neutral perspective.
Our mission is to analyze global defense and space systems through technology, not conflict.
Thank you for watching this in-depth documentary on the military race in space. If you enjoy educational aerospace content, please subscribe and support Channel Militarist.
Share this documentary to spread knowledge about space technology and global security.
Stay tuned for more in-depth aerospace and defense documentaries.
From orbital systems to next-generation aerospace platforms, we continue exploring the future of technology.
Space remains vast, silent, and filled with possibility.
Its future will depend on cooperation, innovation, and responsibility. The race in space continues, guided by technology and shaped by human choice.
In the silence of orbit, technology moves with quiet precision.
Layer upon layer, orbital infrastructure supports life on Earth. Below, billions depend on systems operating far above the atmosphere.
Behind every orbiting system, dedicated teams guide and maintain operations.
In space, boundaries fade, and cooperation becomes essential.
The frontier continues to expand toward the moon and beyond. Responsible operation ensures the sustainability of the orbital environment. Space remains a shared domain for all humanity.
Thank you for watching Channel Militarist, where we explore aerospace and military technology in an educational and neutral perspective.